got an interesting little design problem I want to solve here. I have this engine design, and this valve cover, the engineering team want to change it from the current alloy casting to a modern sort of plastic design. So they've asked me to look at the feasibility of that and see if there's going to be any issues with sort of a structural or sort of vibration performance. So I thought this might be a good example to show how Creo Simulation Live might be used as part of this process. So what I'll do is I'll open this part up, and you'll see that it's designed in such a way for a casting. And what I might want to do is just baseline the current analysis, or the current design. So as I said, it's made out of aluminium, and what I'll do is a modal analysis and maybe just sort of fix the face where the gasket surface would be, and as it's bolted down into the car. And at that point, or at this point, I can already do an analysis and get sort of like a baseline level of the first mode natural frequency, 900 hertz. So it looks something like this. And the natural frequency of a part always gives us an idea of, the stiffness, how it, and also how it sort of wants to vibrate in certain ways. Anyway, but the stiffness value can kind of be set there. So what I might want to do now instead is compare it to if I use some kind of plastic, like an ABS plastic. Let's just assign that over that material to the part, and instantly the analysis is updated for me. And you'll see that the value of the first frequency is now down at 300 hertz. And this is a little bit problematic, I'm told. We're going to try and avoid 300 hertz if at all possible. So what I can now do is have a look at what sorts of design tricks I can play to try and either modify this existing design, because I don't really want to have to design the whole thing again from scratch. So perhaps one thing I can do is to put a rib at this top here, because I could see that it was breathing, kind of splitting apart. So if I put a rib in there somewhere, then maybe that would be appropriate. So I'll just use my standard modeling techniques, put a center line somewhere through like this, and I'm just thinking of all the different ways that I can possibly address this problem. And maybe I'll just do a simple rib this way. Maybe make it a little less dished. And you can see it's very quick to add that rib. Maybe I'll make it about 5 millimeters thick, something like that. And as soon as I regenerate the model, you'll see that the simulation results is already giving me indication that we've gone from 300 hertz up to 350 hertz, which is going in the right direction. So I know that this method of adding ribs might be a good way to address my design problem. And you can see that the value of having the simulation results absolutely in real time as I'm doing these design decisions it's incredibly valuable. It's a real way to change the design process for the better. In fact, I'll just do one more change down here and resume a couple of ribs that I had put in earlier, and you'll see that I'm able to bump that value of frequency up to nearly 380 hertz now, away from its original value, which was something like what did we say? About 300 hertz. So I've made good improvements by doing these kinds of real-time studies for the vibration right inside my design environment of Creo. And that is the value of Creo Simulation Live.